So we're going to finish off our unit, finish off section 2.4 by looking at some graphical and numerical derivatives. We're largely going to see how to deal with these in terms of chain rule, but also some product rule, quotient rule, those things might creep in as well. Can you please get out the worksheet titled section 2.4, practice with graphical and numerical derivatives. And let's take a look at this. We have the graph of f of x and g of x. I'm telling you that h of x is f of g of x. I'm telling you that s of x is g of f of x, and I want you to find the various derivatives that I'm asking for. H prime of 1. Well, first of all, I know that h of x is f of g of x. And because there's one function inside another function here, we need to use the chain rule to find the derivative. I'm going to say that h prime of x equals, chain rule says take the derivative of the outside function, leaving everything inside there, so f prime of g of x, times the derivative of the inside function, times g prime of x. I'm now going to go plug in 1. And I've got h prime of 1 equals f prime of g of 1 times g prime of 1. To evaluate this, well, I'll do what I usually do with these, and I'll start on the inside and work my way out. I need to figure out g of 1, which means tell me the y value on the g function when x equals 1. Well, when x is 1, my y value is 4. This problem is going to become f prime of 4 times g prime of 1. Okay. Well, to find f prime of 4 and g prime of 1, you need to go and you need to find the slope on the graph that we're looking at. F prime of 4 means when x equals 4, tell me the slope on the f function. Looks to me like that slope is -1. G prime of 1 means tell me the slope on the g function when x equals 1. I think that slope looks like down 1 over 2. That looks like -1/2. So -1 times -1/2 will give us +1/2. Next, s prime of 5. Well, s of x, we were told on the top, is g of f of x. Take a moment and find your derivative. So we're going to get s prime of x equals derivative of the outside is g prime, leave everything inside there, times the derivative of the thing inside, so times f prime of x. We need to go and plug in 5, and I've got s prime of 5 equals g prime of f of 5 times f prime of 5. Next thing that needs to happen, you need to go find f of 5. What's f of 5? F of 5, okay, 5. My f function, I think f of 5 is 6, so this becomes g prime of 6 times f prime of 5. Next, go figure out g prime of 6. What's g prime of 6? G prime of 6, which means tell me the derivative when x equals, oh, hold on. Looks like we've got a sharp turn at x equals 6. That's not okay. That means this derivative, g prime of 6, is undefined or does not exist, which means I don't even really care what f prime is. You take something undefined, multiply it by a number. You can't do that. This derivative is undefined. You can't do this problem. Or I'd be okay with you saying does not exist. Either one would be okay as far as this is concerned. Next, let's take a look at 3. H prime of 3, well, we have that same h function that we already dealt with. We've already calculated our derivative in general. So I'm just going to go take that answer and plug in 3, and I'm going to say h prime of 3 equals f prime of g of 3 times g prime of 3. I'd like to see if you can finish off this problem. Tell me what h prime of 3 is. Okay, starting on the inside, g of 3 is 3, I believe. So this will become f prime of 3 times g prime of 3. F prime of 3, I don't think so. F prime of 3, it's undefined there. We're not differentiable there. So we can't really do this problem, and we'll say that this derivative is undefined. You go do number 4. I'm going to take the formula I already created over there. S prime of 9 equals g prime of f of 9 times f prime of 9. I'm going to go and plug in here g prime of, okay, f of 9 looks like 8. So we're getting g prime of 8 times f prime of 8. G prime of 8, well, my slope there looks like negative a half. F prime of 9, my slope here looks like positive 2. So I'm thinking negative 1 for that answer. The next thing I want to take a look at, some numerical derivatives. I really don't think I have to say much about number 5. I want to see if you can go handle number 5. See what you can do. Find h prime of 1 if h of x is f of g of x. Okay, so first of all, my formula is going to look like h prime of x equals, just using chain rule here, f prime of g of x times g prime of x. I'm going to plug in 1, h prime of 1 equals f prime of g of 1 times g prime of 1. I'm going to start on the inside. G of 1, when x equals 1, g is going to be 2. So this becomes f prime of 2 times g prime of 1. Let me go pick those values out of the table. F prime of 2 is looking like negative 1. G prime of 1 is looking like also negative 1. So we're going to get 1 for an answer. Now, moving on. These start getting a little bit more complicated, and the variations I'm about to show you are variations the AP exam really likes. They really like kind of mixing some just f's and g's with some actual functions, x, x squared, sine x, things like that. So let's see what we can do in a problem like 6. H of x equals x times f of x squared. That multiplication tells me this is going to be a product rule problem. I need to go use the product rule. So first let me label this as product rule. H prime of x is going to equal. Product rule says first times derivative of the second. First is x times. Gets a little strange now. The derivative of the second, f of x squared, that's a chain rule problem because there's something, x squared, inside the f function. I'm going to take the derivative of the outside, leaving everything inside there. I'm going to say f prime of x squared. And by chain rule, I'm now going to multiply this by 2x. Let me say that one more time. I'm using product rule here, although I'm only halfway through that. I did my first times derivative of the second. To do the derivative of f of x squared, I need chain rule. I took the derivative of the outside. Derivative of f is f prime, so f prime of x squared. Times, by chain rule, the derivative of the part inside, the derivative of x squared is 2x. Plus, now I'm going to go do second times derivative of the first. This is much easier. Second is f of x squared Derivative of the first times 1. Let me clean this up, and then we'll go plug into it. H prime of x is going to equal, let me call this 2x squared times f prime of x squared plus f of x squared. I think I needed to give you a little more room in this problem. I want to find h prime of 2, which means 2 times 2 squared times f prime of 2 squared plus f of 2 squared. H prime of 2 is looking like 2 times 4 times f prime of 4 plus f of 4. You go finish this off. Go get your values from the table and submit your answer. F prime of 4 looks like 1. F of 4 looks like 5, so 8 plus 5, we're going to get 13. Next one, number 7. If you look at this, I think your first guess is quotient rule, because I see a quotient there. It's not just g of x in the bottom, though. It's the square root of g of x, so the derivative of the bottom will involve chain rule. You know what? There's a way to make this easier. I want to do what we did in that third example on the 3 more chain rule problem video. And I'm going to turn this quotient into a product, which is pretty much always going to be my trick if the derivative of the bottom will require chain rule. If this was just over g of x, I would leave it and use quotient rule. But if I'm going to have to use chain rule on that bottom, it will be easier if I write it as a product. So I'm going to say this is f of x times g of x to the negative 1/2. I'd like to see if you can take a moment and work through your product rule. Don't plug in anything yet. Just go do your first times derivative of the second plus second times derivative of the first. I'll make the video pause. H prime of x equals first f of x times derivative of the second, negative 1/2 g of x to the negative 3/2 times g prime of x, first times derivative of the second, plus second times derivative of the first, should look like that. I guess there's a little bit of cleaning up I could do. Maybe it doesn't matter. Maybe this wasn't necessary. Then we need to go plug in 3. H prime of 3 equals negative 1/2 f of 3 g prime of 3 times g of 3 to the negative 3/2 plus f prime of 3 g of 3 to the negative 1/2. Take a moment, pick out your f of 3, g of 3, f prime of 3, g prime of 3 from the table. This should give us negative 1/2 times, okay, f of 3 is 1, g prime of 3 is 3, g of 3 is 4, which I'll raise in a moment to the negative 3/2, plus f prime of 3, get that from your table, that's 2, g of 3 is 4 to the negative 1/2. This gives me negative 1/2 times 1 times 3 times 4 to the negative 3/2. That's 1 over 4 to the 3/2. That means square root of 4 is 2. Cubed gives me 8, so I'm going to say 1/8 over there. Plus 2 times 4 to the negative 1/2, 1 over 4 to the 1/2, 1 over the square root of 4 should give me 1/2. I think this is negative 3/16 plus 1. Rather than 1, how about I say add 16/16? And I think we're going to get 13/16 by the end of all that mess of work. 2 more of these. Number 8. H prime of 2 if h of x equals this thing. Take a moment, see if you can write out a formula for your derivative. So this is chain rule, and actually it looks like 3-part chain rule to me. I see a square on the outside, an f inside that, and a 2 times inside that. I'm going to first deal with the outside. I'm going to deal with my square, leave everything inside there. Then I'm going to deal with the f. Derivative of f is f prime, so f prime of 2x. Then I'm going to deal with the derivative of the inside. Derivative of 2x is 2. Might as well clean it up, and I'm going to say 2 times 2, that's 4. F of 2x, f prime of 2x. See if you can now plug in your 2 and get an answer for h prime of 2. F of 4 looks like 5. F prime of 4 looks like 1. We're going to get 20. One more. H of x equals x to the 9th plus 5, plus f of x, that whole thing raised to the negative 2. We want to find the derivative of this. I'm going to make the video pause. You see what you can do with this. Looks like chain rule to me. Deal with the negative 2. Leave everything inside there. Then multiply by the derivative of the inside. See what you can do. I'm going to pull down that power. Leave everything inside here. X to the 9th plus f of x. And my new power is now negative 3. Then I have to multiply by the derivative of the thing inside. And the thing inside was a sum, so I need to multiply by a sum. Derivative of x to the 9th is 9x to the 8th. Derivative of f of x is f prime of x. We're going to get h prime of, why don't I just start plugging in? H prime of 1 equals, actually, you know what? How about you see if you can go deal with the plugging in and send in your answer. Negative 2 times 1 to the 9th plus f of 1. When I'm done, I'll raise that whole thing to the negative 3. 9 times 1 to the 8th plus f prime of 1. Okay, negative 2 times 1 plus f of 1. Okay, pulling that out of my table, f of 1 is 3. I'll raise that to the negative 3rd. Times, okay, that's a 9 plus f prime of 1 is 1. So, negative 2 times 4 to the negative 3rd times 10. 4 to the negative 3rd, 1 over 4 cubed is going to be 1 over 64. Times 10, I'm thinking negative 20 over 64. We can divide by 4, so negative 5/16. My plan for next Wednesday is to try to do some group work with you guys when we're on our remote Zoom day, practicing with some of these, because I think these would be really good for you to discuss with some other people and see what you can do. And this does it for Unit 2 on basic derivative rules.